All right, thank you, Sam. So again, I'm Keith Gamble, faculty in economics, finance, and data science. And I'm excited to present to you today on running open source AI on your own machine. So I want to start with just some AI terms and concepts to understand the significance of what I'm sharing today regarding open source AI and running it on your own machine. Why is that significant? So in person, we have our physical handouts. If you don't have one, I have some more. And then on Zoom, I put the file in the chat, and then you should see it on the screen as well. So when people are using AI in the world, most people are using what's called frontier models. These are the AI models that are pushing the boundaries on what's possible. If you're using ChatGPT from OpenAI, Anthropic's Claude, Google's Gemini, you're using a frontier model. The issue with these frontier models, one of them is that they are closed source. So they are kept private and they're not available to be downloaded. So when you're using a frontier model, like when you use ChatGPT, you are necessarily using what's called the cloud. And the cloud is accessing data or programs over the internet instead of on your own computer. So if this wasn't news to you, this is really, really important news. And I'm glad you're hearing it if you didn't already know that when you put a prompt into ChatGPT, that does not live just on your own computer. But when you type that prompt into ChatGPT, that prompt goes out over the internet to a large data center, which processes your prompt inside the model, produces output, and sends it back to your computer. So I will share what a data center actually looks like. So here is an image of Meta's completed data center. This is the one up in Gallatin, Tennessee, an 800-acre data campus, which I believe is still under construction. I think these are the three first main buildings, and I believe there are two more additional in that upper left area that kind of looks like it might be for future construction. In previous years, I actually got a tour of this data center when it was under construction, and it completely blew my mind what was happening in Gallatin, Tennessee with these data centers, and the scale is just enormous. Inside these buildings are just computers, and they're just running prompts that are sent to the cloud or other such things. So that we can have the best models with speed on our system. So there are now dozens and dozens of data centers like this, and there are dozens and dozens and dozens more under construction across the world. All right, so this is frontier models and closed source models in the cloud. And you might wonder, well, if those are the best models, why wouldn't we all just use frontier models all the time? And there are some reasons, especially for faculty and staff, not to exclusively use the frontier models. So number one, FERPA is a federal law that limits disclosure of student educational records, okay? So we get into a really murky question if a faculty asks, can I send my students' work off to the cloud to be processed in a data center so that I can get the AI analysis I need on my students' educational work? And I'm no lawyer here, but I would say be very, very careful with that. And that's why I started with, like, when you use the frontier models, what you're doing does not live only on your machine. You're sending information out to the internet. So if you upload student work, know that you just sent it to a tech company data center somewhere. Now, there are many of these tech companies promising, we won't do anything bad with it, okay? But remember, these are the same tech companies that knowingly stole copyrighted content, and they're being actively sued in court. So how much do you trust the tech companies to keep your best interest at heart? Other issues for faculty and staff, I know in my research in the College of Business, we have some amazing data sources that we have licensed from the Centers for Research and Securities Pricing. And as much as I would love to just send that data to a data center and then get the AI output that I want from it, I don't know that I have that right to use the data in that way, because in using these frontier models, I am sharing this data that's not really mine to share. So that's a concern. If you're using sources, like maybe you have licensed sources in your research and you want to use AI models, but you don't own the copyright of those resources, I would just be careful of sending that to the cloud. Similarly, if you're doing confidential research, which does happen at MTSU, there's some research that is sensitive, scientific, progress is being done, and certainly the federal government doesn't want your proprietary research just being sent around the world to data centers. If you're doing confidential research, or if you're in a situation of limited data access, there's a lot of faculty that work in field sites. And at your field site, off in the farm or out in the mountains, you don't have internet access, but you would love to have AI to use. Well, there is a way, okay? And that's what this talk is about. Similarly, on the plane, I think most of us still experience working on the plane, and either you don't have Wi-Fi or the plane has Wi-Fi, but it's not working, which is always seems to be not working on the plane, but you actually need to use AI. Well, you don't have access to the frontier models because you don't have that internet access. So this is the case for why it's important, or why it's potentially really valuable for faculty and staff to know about open source AI and how you can use AI on your own machine. And so by that, I mean, like, you could turn off the internet. You could be on a plane without Wi-Fi, and you could be using AI on your computer, and you're not sharing that data out there with the world. All right, so let me stop there for a second, see if there are any questions so far.
These ethical concerns that you're expressing in terms of MTSU, would you say they also apply in K-12?
Do they apply in K-12? I don't know about the law. I would say there's certainly some ethical issues of teachers sharing student work in the K-12 context.
Yeah, I mean,
that as a
still
parent,
applies.
I
Yes.
might be really
Yes.
mad if
Yes.
my, third grade son's work was out there shared by the teacher, and that didn't portray them in a flattering light, right? So yes, I think there are some ethical issues, if not legal issues, for K through 12.
Okay, thank you.
How would you define LLM as a term?
LLM, a large language model. It's a large language model. You're going to see a little more about what large language models really look like today as we go to software that allows us to download an open source model. Like, you literally will download the whole model to your computer. And so you'll see how many gigabytes large actually means. Other questions? And those of you online, welcome questions via the chat. Dr. Zaza is monitoring the chat during this talk. All right, so continuing in the notes, open source means software made publicly available for everyone to view, use, and modify. And today I focus on software that's called Olama. And Olama has made it as user-friendly as possible to use, or that's certainly, I think, the best in the world of making open source models accessible to the average user on everyday consumer grade systems. All right, so there's been like computer scientists and other scientists using open source models for years, but Olama is really the software I think that democratized this use. And a few months ago, they moved from a command line interface, which felt like your computer programming to use, to a graphical user interface very similar to ChatGPT. And when that happened a few months ago, I was like, oh, I gotta do a workshop on this, because anyone at the university can use this software and they can run open source models on their own machine. So let me go back to my Chrome browser, and then I'll switch over to olama.com. So olama.com. Olama is an open source tool that allows users to run large language models on their own computer. All right, so here's olama.com, free to access. You don't need an account to download the software. It is free to access and use. It does have a sign in button, and you can create an Olama account, but you don't need to download the software. You just have a download button on the front. This is available for Mac, Windows, and Linux, which pretty much covers it. If you have like a Google Chromebook, sorry. But for most consumer machines, this is going to work. So you can download. When you click download, it will ask you to select what operating system you have. Now it knows I'm on a Windows system, and it has download for Windows as the default for me. And so when I click download for Windows, you will start downloading Olama software in your browser. The Olama software is not that big. It shouldn't take that long to download. And this is going to run just like any program you download from the internet. Every time I get a new computer, one of the first things I do is download the Chrome browser. I love the Chrome browser. Google has all of my personal information for most of my life. I've learned to trust them. And so as soon as I get a new machine, I download that Chrome browser and then run that file. And it's the same kind of thing to run Olama software. Now, I already have downloaded it and installed it. I'm not going to install it again, but it's not complicated. You just run the file that went to your downloads folder, click on that executable file, and then you will be running Olama. All right. So that's how you can get Olama on your own system. What models can you access on Olama? You can access models that have been open sourced. And this is an ever-changing list. So all I did on the Olama page is click the model tab in the upper left, and you're taken to the list of models. This is currently sorted as the most popular models. So at the top of that list is GPT OSS. It's a new open weight model by OpenAI. So until this model, OpenAI's models were all closed. Despite the name OpenAI, they only generated closed models that were proprietary and not shared with the rest of the world. And this is not that long ago. It was updated 3 weeks ago. They released this model, GPT OSS, which is a new open weight model of OpenAI. Now, is it as good as the frontier model running when you run prompts on ChatGPT, the GPT-5? No, right? These are not frontier models, but I'll tell you, open source models are pretty good, and they're getting better rapidly. All right, some other models of note here, Quinn 3, and you'll see VL. The VL signifies it is a vision model, the V for vision. You'll see the tag for vision on some of these. If you want to do things like image recognition, you need a vision model. Not every model is going to be a vision model. You'll see things like thinking tags. Thinking is ability of a large language model to generate text, to kind of artificially think about a problem, generate text that will help guide the model to a correct answer. So we'll see in the live demonstration soon what that means. But some of these models do have the thinking ability and others don't. Some do have cloud ability. You can use Ollama and be using a data center. All right, I'll show you in a minute how to turn that off if you really want to isolate your data from the data center entirely. But there is a way to use what's called turbo mode. Well, the way you get turbo is you send your prompt to a data center, which has like amazingly fast computers, and that's what makes it turbo. It doesn't make it turbo on your own computer, but that's what the turbo you'll see in a minute means. And then another thing I want you to pay attention to in this list of models is under a model, and let's focus on one that we're going to use at the start, and this is Gemma 3. So Gemma 3 is a model that was produced by Google, and you'll see these numbers here, 1B, 4B, 12B, 27B. What's that describing is the number of parameters in the model. So how large is this large language model? And that's literally the number of parameters, that's the number of weights and biases in the model that make it work. So the larger the model, generally the better its performance. But the larger the number of parameters, the bigger the download's going to be to your computer. And then even more importantly, the larger the parameters in the model, the better and faster machine and memory you need to actually run it. All right, so when we go in to start using Ollama, my recommendation is for whatever model version you're choosing, like for the Gemma 3 model, start with the low parameter model first. Try it out. Does it run on your system? Probably it does run on your system in, say, the 1 billion parameter model, but I'm not going to guarantee that all of your systems are going to run the 27 billion parameter model. It's substantially bigger and it takes more memory. It takes a higher level of computation to get results out of that model. All right, at this point, any questions?
When you say parameter, what do you mean? Usually people ask that question.
Yeah, what is a parameter? It's literally a number that's been baked into the model. And what does that number do? It's either a weight where it modifies another number by like multiplying the weight with that number, or a bias, which adds that number to another number as input. And so literally these large language models, these AI systems are just a giant stack of numbers, and each number is a parameter. Now, how does that work, right? That's sort of the magic of a neural network, and it's even surprised the scientists who built it, okay? But through the training process, that just giant list of numbers, literally in the 27 billion parameter model, a list of 27 billion numbers in a network, a neural network, like that's all it is, right? It's just a bunch of numbers on your computer. Now there's a whole process of like turning your prompt through tokenization into numbers to input to the model, but that's what's happening. Like it's just turning your text into numbers and throwing it in this model, and then it does a bunch of computations, and out the other end it starts spitting out words. Okay. One nice thing about this open source, and you'll see this in a minute when we start doing demonstrations, is that sense in which these AI models are just predicting words one at a time. It's really lost when you're using the frontier models, because you type in a prompt, enter, it's like, boom, your screen fills. That's because it's just super fast. When you use it on your own system, you'll start to see like, oh, I get it, one word at a time, and we'll like watch the words be produced. Yes.
Just to repeat what I think you've already said, the smaller or the larger the number describes its capacity, its speed, its capacity to hold information, to process information, the speed of the information, the efficiency of it.
Yeah, where speed is
storage space.
inversely related to that number. So the larger parameter models are generally more capable, but then they also take more computational intensity. So on a given system, the larger the parameter, the slower it's gonna run, right? But I suggest starting with the lowest parameter model and then seeing if it works for you. If it works for you, just keep using it. But if you're like the quality of this output's not good, then step up to a higher number of parameter model. Generally, higher parameter models work better in terms of quality, but they're always slower.
So the bottleneck is the computer, the MTSU put on my desk 5 years ago.
Yeah, right. And like I want to get into that a little bit before we start because I've observed in my time in higher education this huge shift. When I started as an assistant professor, it was a different university, but 2009, it was like you needed to have a big machine to run your research. To capture all the data we used in finance. I needed a big machine with lots of hard drive and memory. And then like 10 years later, 2019, it was like, you don't need a big machine, right? Everything's on the cloud now. You just need to, a simple machine. And now you can make a laptop and portable and all that, right? But I think the more people start to use open source AI and see benefits of that, the more the university is going to see demand from faculty saying, I want a beefy system, okay? Because these open source models, they're not frontier models, they're not the ones that the data centers are running, but they have been produced for the general user, and most systems are going to be able to keep up with these. I did note that nothing I'll demonstrate today on this system is going to generate images or video. It's not that it's not possible. It is possible to generate images and videos now, open source your own computer, but not this laptop. Like this laptop was not bought for doing open source AI models. This laptop was bought for travel, okay? So it's not an expensive laptop, it's not special, but that's kind of the point of this. What can you do with your own systems now? But if you continue in this direction of wow, this really works for me, for my research, this is so important, for my work with students and student data, this is so important. This came out very recently, and it's coming up on my web browser. This is NVIDIA. It's the company that has achieved the highest stock market valuation in history, I think like $5 trillion. NVIDIA produces the GPUs, which are the heart of AI systems, and they have created their own computer on a desktop. This is the NVIDIA DGX Spark, 4 terabytes. They describe it as a Grace Blackwell AI supercomputer on your desk. It gives the specifications of this computer, and you can buy it now for under $4,000. All right, so to my knowledge, not a single person has this at the university. This is brand new. There are some people at the university who have some really powerful systems and run AI models on their own machine. But this is the first computer I've seen marketed that really tries to go at a broad scale audience who wants to run AI on their own system. All right. If we were using one of these suckers, I imagine we could run every single model on this list and it would run super fast. But you will see that on my travel laptop, it's not going to run super fast, but well enough for a lot of purposes. If you are interested in creating images or videos, and you can do this, a non-specialist, you can download some software called Comfy UI. The user interface is so much more complicated than Llama, but with some YouTube tutorials, you can get enough knowledge to be creating images, be creating videos within a couple hours. All right, for images and videos, because of the computational intensity of that activity, you need a beefier computer. the best computer I have access to can do this. But when that GPU starts running and producing a 5-second video clip, it gets hot. And it's like a heater in the room, right? So that was really illustrative of me of like all these environmental concerns, data centers and cooling. Like when you start running a model, an open source model to create a video clip, it's like watch the task manager. It keeps track of the temperature of your GPU. And if your GPU gets up to 80 degrees, you'll feel it. It's like a warmer in your room. And I was like, the first time that happened, I was like, whoa, I get it. Wow, we're using a lot of energy to make that video. Okay. All right, so let's get into the demonstration portion of this. I want to now screen share to Olama. All right, so there's Olama on my laptop. It is, all right. Sorry, if you're in the room or if you're on Zoom, I don't think you can see this because I'm screen sharing the application. But this little icon in the middle of the screen is that llama, the white and black llama icon.
Is this better?
Yeah, a little bit in the room at least. That icon is the icon you click to start up Olama software. So you can't see my taskbar, but that's it. I have an icon on my taskbar. I click to start a llama, and you'll notice it looks a lot like ChatGPT. So here in the middle, there's a box to enter your prompt. On the upper left, and that, wow, it's really hard to see, but the upper left, you see there are these little icons where you can do things like create a new chat and so on. But it basically works just like ChatGPT. So really clean user interface. All right, so I'm gonna start these demonstrations with the Gemma 3 1 billion parameter model. When I click here where it says Gemma 3 1 billion parameter, you'll see the whole list of models. You'll see that the other Gemmas, including the 27 billion model, are available. But as I recommended, start with the lowest parameter model and see how it works. All right, so how do I get that model on my system? Because I didn't download that model when I downloaded the Olama software. I just downloaded the user interface. So what you do, I think this is really straightforward, right? You just select that model and then give it the first prompt that you want to use. When you give it the prompt for the first time, it's going to download right here in Olama, and you will watch the little download bar. Okay, now I've already done that, and be grateful because these are some big files, right? Like more than a gigabyte for this model. So it does take a little bit to do, but these are already downloaded to my computer. So, first example, these are examples you've probably seen before, but this is now on my system. I do want to show you something in settings. All right, so I clicked here in the upper left, go to settings, and I have turned on airplane mode, okay? Airplane mode is gonna make sure that I don't have an option for turbo, which is a way of using Olama on the cloud. The kind of purpose of this workshop is to show you how to use open source models on your own system. So I have selected the airplane mode. So this is not going out to a data center. I also lose what's called retrieval augmented generation. If you're using ChatGPT, for instance, you can have it take sources from the web and incorporate that in its response. In turning on airplane mode, it's not going to do that. It's not going to grab new stories from the web. So I'm literally only using the information that was baked into this model. And Gemma 3 came out not that long ago, so I'm not that worried about it. But as these models age, if you're not using an updated model and you've turned on airplane mode, so there's no retrieval augmented generation, you might find some of the model becomes out of date. Okay. All right. All right, so back to use. So here's an example. I'm on the plane and I really need to write the editor and request another week of time for my revision. And it'd just be so nice to get that done quickly. So here I'm gonna use Gemma 3, the 1 billion parameter model, and ask it to draft an email to the editor requesting an additional week for my revision. And it's going to start. All right, so let's see if I can make it a little bit bigger. This is Gemma 1 billion parameter model. It is drafting my letter. Because it's the 1 billion parameter model, it's gonna be the one that works the fastest. But remember, the lower the parameters, maybe the quality is not gonna be as appealing. All right, but that wasn't bad. Just a few seconds to produce this draft letter. Dear Mr. Miss Editor, I'm writing to respectfully request an additional week for revision of my manuscript. Blah, 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 blah. I read it over and maybe edit a few things, add in my name. And in, a couple minutes, I have completed my task. I got my draft email is written. So you get a sense of how this works and what it looks like. Really not bad for some kind of task like this. But we can ask other things. Another example, we'll stay in the 1 billion parameter model here, is AI is very good at explaining topics. Very good at explaining topics. So we had a previous question about what is an LLM. So explain how a large language model works in simple terms. All right, let's ask Gemma 3 1B. And it goes at its task, literally just predicting words one after another to try to sort of please this prompt, try to be consistent with this prompt and what it might mean. All right, so it says, so just briefly look at this. Think of it like teaching a super smart parrot how to speak and write. There's a training process of feeding the parrot lots of words. That's like the massive data sets used in training large language models, where it starts to learn patterns from that massive amount of data. And then there's a neural network behind it, and so on. All right, so there is the explanation. It's nearly done. And again, this is not going out to the cloud. This is running on my own computer. All right, now if you find this satisfactory, then I'd say stay and continue working in this model. But let's take a look at what the larger parameter models look like and how they work. I'll start a new chat. I just need to change to the different model name. Here's Gemma 3, 27 billion parameter model. I forget exactly how big this is, but it's going to be more than a 10 gigabyte file. All right, it's going to take a while because it's got 27 billion parameters, numbers baked into the model that it uses to produce these words in our output. But just as a simple test, let's try the same explanation. So explain how a large language model works in simple terms. And one thing to notice that's different about this is going to take longer to load. Okay, it's loading up this model in my computer's memory. And that takes a little time because it is a big model. I can go in Windows to what's called Task Manager. And in my Task Manager, select System. And you can watch in System. Is that appearing on the screen? No. Let me go to Screen Share, over to Task Manager while this is working. All right, there it is. So this is CPU utilization. You can see when I started the model up, the CPU kicked into action and now it's running. And boy, you can really see it with memory. So when I started up the model, it had to load this model into memory. And I only have like 4 GB available of my 32 GB memory on this computer. So it loaded up the model into memory. And this is among the open source models, this is a reasonably big 27 billion parameter model. All right, let's go back to a llama. And wow, you can really notice the one kind of word at a time of this model. It's a much bigger model that tends to produce higher quality results, but on my travel laptop, it's really struggling. Okay, so that's a example of difference. If you have a beefier computer, more memory, higher processing power, maybe a dedicated GPU, this might run perfectly at a reasonable speed, but I'm definitely testing the limits of this system.
What chip do you have in that machine?
What chip do I have in this machine? Let me go look at my task manager. I click on my CPU and it says Core 7, Intel Core Ultra 7. So it's an Intel CPU. But this is designed more for battery life and travel than it is a beefy laptop. It's not what a computer scientist or creating their own models would want to use. So I'm gonna put this out of its misery if I can, because oh no, I think it's even stopped. Let's see. Uh, the new chat. All right. Well, it's still running, but what I've learned is that the 27 billion parameter is definitely over. If you find the 1 billion parameters is just not high quality enough, step up to the bigger model size, but it's kind of a trade-off with speed and quality. That also does depend on the use. Okay. So Gemma, does Gemma have thinking? That's what I wanted to test. All right, let's go back to Gemma 1B. So here's the small model. I wanted a prompt to try to get at the thinking abilities. So I'm gonna give my Gemma 3 1 billion parameter model a logic puzzle. This is a good simulation if you're trying to use AI for like research purposes with a lot of complicated prompts. You might need a thinking model to do it. So I'm gonna give it a classic logic problem, which is a bat and a ball cost $1.10. The bat costs $1 more than the ball. How much does the ball cost? All right, so you can run that through your own human head. This is a logic puzzle that trips up a lot of people. Let's see how Gemma 3 1 billion parameter model does. A Gemma 3 model is produced by Google, which is a very high quality tech company, knows how to build models very well. And it's spitting out some words. It looks like it's taking an algebraic approach. And it might actually get there. Let's see. It sort of gets some of the idea, but it seems to be spinning on this issue, not quite realizing that it's gotten somewhere. And wow, it's working. Hmm. It doesn't seem to know when to stop here. And it just keeps trying things. All right. So the final answer is, it's a weird way to say 5 cents, but the ball does cost 5 cents because the bat's $1 more, it's $1.05. Together they cost $1.10. So even the 1 billion parameter model did solve it. Pretty convoluted how it got there. Let's test a model that is built more for thinking and see if it does better. So I'm pretty sure, yeah. So this OpenAI release, and that was the top of the popularity list, is this OpenAI model GPT OSS. It's a 20 billion parameter model. It's explicitly a thinking model. And you can even set here on the left, you can set different levels of thinking, low, medium, or high. All right, we'll just keep it in the medium domain, but I want to see a thinking model do this. Can it reason out the logic and give me a more straightforward answer? All right, so a reasonably big model, 20 billion parameter model, it's now got to load into memory. So the 3 dots you see sort of waiting is not surprising. It's loading up this model, 20 billion parameter model might be 10 gigabytes.
Can it create agents?
Can you create agents with this? I can't. I don't know how to do that. But some of these models, and I think the OpenAI one does, has tool ability, which you need for agent use beyond my capabilities, but I think it's possible. Yeah.
I mean, the user.
I think it is possible with open source AI. Make sure you select a model that has the tool capability beyond my personal capabilities with open source AI though. All right, still thinking. That's okay. We will give it a second to think.
So how do
Actually,
you
I think
see
it's-
this working for our faculty? What advice do you have for our faculty?
Yeah, it's early days. So I think some people are gonna look at this and go, I'm not ready for me. I'll stick to the frontier models. Like I'll use it for limited purposes. But I think more and more we're gonna find ourselves in situations of like, I really need AI for this, and this is not something I can send to the cloud comfortably. And that's where I think some knowledge of what's possible in your own system can be really, really useful. Now, my research is not confidential, and I'm not using a lot of proprietary sources that I can't share. So it's not so important to me right now, but I know for some people, right, you're working in the field and you would love to have AI access, you have no internet access, or you find yourself in a situation that you want to analyze some student data, you want AI help. Here is a solution. Also know that these models are getting so much better. Okay, the models are getting so much better where they're going to run on more and more systems. They're going to get to correct answers faster. I do think though, like people who leave this workshop and go, oh, I know, I'll use this right now. That's more limited than general. But I think over time, this is going to become even more important for people. All right, so it thought for 17.6 seconds, and it gave us this extremely straightforward answer. The ball cost 5 cents. The bat being $1 more expensive cost $1.05. Boom, okay? That's a pretty high quality answer to this logic puzzle. How did it avoid all of that just like going around in circles? Well, that's in part because of its thinking ability. It sort of figured it out before it spit out an answer that was wrong, right? If you're doing complicated research, you're doing, this would be the model I would go to for complicated questions. I wouldn't start at Gemma 3 1B, but if I'm like on a plane and need to draft or want to learn about some topic, I can chat with Gemma 3B and it's gonna handle all that really well. All right, so I also wanted to demonstrate that you can, with these open source models, if it has vision, it can do image recognition, okay? Let's go to Quinn 3, 4 billion parameter model, and it's specifically marked BL, so it has the vision. The V is for vision. Let me go to a new chat. And earlier we had that data center image just to test this vision model. I'm going to upload into the model. I just clicked on this plus button. I uploaded into the model this image here. All right, so I'm going to ask it. I'm going to test its vision capabilities. Identify what is in this image. All right.
If you upload it, not me, the user uploaded a celebrity image with identifying is that person.
If you would identify a celebrity, I would have to test it. I haven't tested that, but it would be interesting to find out. But this has lots of potential use in research. Here you have on your own system image classification. So you have a bunch of images that are maybe taking pictures of plants. You work in agriculture and you want to identify the plants that need certain nutrients to grow, or they have pesticide related issues or something. I'm obviously not in agriculture, but there's lots of work that depends on systems that are taking images, and then you need to have an understanding. Can a machine do that for you on your own system? Like, absolutely. So here is Quinn 3. It has vision capabilities. It took this image of the Meta data center in Gallatin, and it's describing this image now. So an image depicts an aerial view of an industrial commercial development area. Key elements include multiple large buildings, paved roads and parking lots, undeveloped land, natural surroundings. So works pretty well in figuring out what's in this image. Now, some of the models don't have vision capabilities, and it just will literally, if you try to upload that file, say, I don't have that capability. It won't get anything. But for a model with vision, now you have the ability on your own system to identify things in images. All right. Questions?
Do the number of data centers affect the efficiency of a?
Yes. More data centers, the faster it can produce results. So I was reading an article analyzing Google search, which has been around for a long time. Google wants to maintain its dominance in the search industry. One of the ways it tries to maintain dominance is by giving you the fastest, best response to any search query. And so this article explained how it's not just one data center, one computer that's kicking out those results, but Google actually has it where it will send your search request to multiple data centers, where maybe the first one is sending out the first result, and then the next one's doing the next 2 or 3 results. And so in combination, you get that full page of results as split second as possible.
So
Right.
in general, are the current platforms and open sources using all data centers like that? Or are they restricted to certain data centers?
It varies. So the biggest tech companies now have multiple data centers. Just read an article this week. OpenAI, who created ChatGPT, signed a $38 billion contract with Amazon Web Services. And what that is Amazon Web Services has data centers, And they're going to put OpenAI's models in their data centers so that now OpenAI can access data centers of Amazon Web Services. It just expands their reach and the amount of data that they can process, right? So that's that whole $38 billion contract was just getting OpenAI more access to compute. And it's coming from Amazon Web Services, which is already built out with multiple data centers around.
You know, the landscape is so new
Hmm.
that, is it the expected practice, just the norm, that data centers will be available to everyone who needs access to a data center?
Huh. Right now, if you go to ChatGPT, you can usually get an answer pretty darn quick, right? But there are questions about how long that's gonna last, right? Before they say, all right, now that everyone wants this and sees what's capable, are you a paid user or not?
Okay.
Right? It's not hard for them to flip a switch and say, we service paid users, right? Here's where you line up to pay your account. All right, so that's a common model and used to the race to like be the first and get the most users. There's no guarantee that they're gonna stay freely available. One thing that does give me heart in this is when OpenAI created their world, I think this is me just putting my own view on things. I think they thought that they would have this huge lead in artificial intelligence. And I suspect they were surprised how other organizations, Anthropic, for instance, Google, how fast they caught up and producing models as good. And my point is, there's a lot of competition in the world, and competition is what's going to keep prices down for the consumer, right? I especially take heart that these open source models have gotten so capable, right? If OpenAI comes out and says we're $200 a month for everyone who wants to use us, I know what I'm doing, which is going somewhere cheaper. And I know for my businesses, I can use this all day, right? Sometimes I can't tell the difference between a frontier model and a model that's running on my own machine. I downloaded it for free, and it's not even a specially built machine, right? So that make, as an economist, I think about these industry dynamics, and I think it's that competition and that open source component that's really going to constrain the pricing ability of these big tech companies to create a major, well, one, tons of money for them, and also a real equity issue in terms of access to these tools.
At 200 a month is only 20 months to get your money back on that NVIDIA machine.
Yeah, I mean, these
Pay for itself.
tech companies are burning through cash, but their valuations keep rising. Well, why is that? Because the potential for how the world changes is what their valuation is based on. The more users that they get, the more they can convince people that that is the future of the world, right? So what's an alternative to all the big tech frontier models, right? Especially if you're bothered by some of the environmental implications and things like that. Well, find a cheap, free, open source model that can run on your system. And if that works for you, stop using the frontier models, right? Many instances, and that's an interesting aspect of GPT-5. When GPT-5 came out, it was sort of released like their latest and greatest version. And then people figured out pretty quickly, oh, it seems just to be like a traffic cop for OpenAI, where if you do a simple prompt, it's going to send you to one of their cheaper, quicker to run models. And only if you do something really fancy, like you're a scientist trying to do new research, is it going to send you to that thinking model, right? So it's really about cost savings for them more than quality for the user. That was GPT-5, right?
Isn't it always?
Okay, OpenAI was not a for-profit company to start with. They had a grand vision of bettering the world and having open access to this latest and greatest tool. Again, my own opinion, but my own opinion is they were doing all of that, and then they realized that they had something that was worth billions and billions of dollars for like each person in the room. And they were like, call the lawyers, how do we undo this for-profit structure? And they're all done. Like, they're making tons of money. People are profiting to the tunes of, there's several billionaires employed at OpenAI, right? That whole like great nonprofit vision for the world, greed took over, and here we are.
Please, let's give Keith a round of applause. Thank you so much. Thank you all who attended us in person, and thank you for our Zoomers. If you have any questions, please let us know, email me or email Keith, and we'll be happy to answer any questions. Thank you. Have a great day.